missiles. Of course, its primary mission is still what the military refers to as ISR, or Information, Surveillance, and Reconnaissance.
It's basically a poor man's satellite. I mean, you can bring it in and let it dwell in an area.
UAVs transmit important visual information to battlefield commanders via satellite or other data links.
Once targets had been located, identified, and cataloged, these could be disseminated to other weapons or weapon systems.
Reconnaissance UAVs have multiple ways of conducting surveillance. On clear days, they use specially stabilized optical lenses that can zoom to high magnification. At night, they use infrared, and under adverse conditions, they use synthetic aperture radar to pierce the thickest clouds, sandstorms, or oil field smoke. When the radar is reflected back, it can also be used to create a 3D image of objects.
If the enemy chooses to use countermeasures or decoys or deception techniques, having to beat 3 systems is a lot harder than 1.
The success of the Predator paved the way for the development of an even more advanced high-altitude jet-powered UAV by Northrop Grumman. It's called the Global Hawk, but unlike the Predator, it was designed to take off, fly its pre-programmed mission, and land all on its own, thanks to the GPS, or Global Positioning Satellite System.
The Global Hawk is basically a much larger version of the Predator. It has higher altitude capabilities, increased payload. It can carry a lot more sensors, a lot more communication devices, and it can loiter over a battlefield for up to 35 hours.
The Global Hawk can stay aloft for a day or more, providing constant near real-time video surveillance over an area the size of Illinois.
Predator and Global Hawk give us an up-close view, which is something you can't get from a national asset, which would be a satellite type of thing.
Though still in development, the Global Hawk had a dramatic impact during Operation Iraqi Freedom. A single prototype provided information to Allied forces on 55% of all time-sensitive targets, including mobile Scud missile launchers. Like the Air Force, the Navy wanted its own autonomous UAVs. However, designing one to take off and land on an aircraft carrier was a tremendous challenge. But the engineers at Northrop Grumman were up for it. In the summer of 2000, they began working on the X-47 Pegasus.
The hardest part of the Pegasus program was definitely the flight controls. Getting on and off an aircraft carrier, of course, is one of the toughest design problems for an aircraft. And doing this with a tailless vehicle like Pegasus certainly was the toughest problem we had.
That problem was solved by using 6 innovative surfaces to make the plane climb, descend, and turn.
This surface just rotates up. The elevon, of course, both up and down, and then there's another inlay on the lower surface as well.
The first flight of Pegasus, the demonstration was very, very successful. It lasted approximately 12 minutes. There was no human in the loop.
But could Pegasus, without any human assistance, land within the tiny space between the arresting cables of an aircraft carrier? The engineers came up with an ingenious way to find out.
And we actually glued a small paintball down onto the bottom of the hook so we could get a clear touchdown point. That was quite an achievement that we're very proud of.
The Navy will use its stealthy UAVs to get targeting information for its guns, missiles, and fighter aircraft.
The initial focus has been on information, surveillance, and reconnaissance to provide targeting information to the Navy's strike packages.
But many future UAVs, such as Boeing's X-45 unmanned bomber, will be heavily armed. Although flying pre-programmed missions, armed UAVs will still need human permission to fire.
It has to know where friendly forces are on the ground, where civilians might be, where collateral damage, i.e. hitting a church or a mosque, might be an issue. So there is an element that we always retain where a human in the loop is important.
You can have a weapon that's doing its own surveillance and has its own ability to engage a target. And that gives you a level of dominance that we're just emerging on right now.
In the not-so-distant future, there will be even more radical aircraft and airborne weapons systems. Everything from electromagnetic pulse weapons to powerful airborne lasers to hypersonic aircraft that can fly to anywhere in the world in 2 hours or less. But how soon will these high-tech secrets become a reality? The enigmatic F-117 stealth jet flew in secret for 10 years before its existence was revealed to the public. Some of the unclassified projects that are acknowledged by the Pentagon seem more like science fiction than reality. The military is designing a weapon system designed to neutralize an enemy encampment or factory without destroying it and scattering nuclear, biological, or chemical materials. Electromagnetic pulse, or EMP weapons, will blast a highly concentrated magnetic field towards its target, overloading and destroying any electrical components.
The small electromagnetic pulse weapons offer some pretty startling capabilities. You can essentially completely destroy an enemy's electronic infrastructure in a very precise way. You can fly over a small facility, only a couple of acres, fire it, and suddenly none of their computers work, none of their weapons work, none of their electronics at all will work.
Researchers are also experimenting with an airborne chemical laser.
An entire aircraft has been turned into a chemical energy plant that points that laser at a target and burns through missiles.
This aircraft will fly at higher altitudes and will primarily be used for Scuds or for ballistic targets that would be fired from one country to another.
American generals don't want a fair fight. They want their equipment to be the absolute best in the world so that whatever they come up against, they can defeat it quickly and efficiently.
The battlefield of the future will continue to be a dangerous place. But military planners believe that the key to maintaining the security of the United States is to develop the weapon systems of tomorrow, today.